All right, here we go. So, finding a vertical asymptote, again, has 3 steps. Factor the numerator and the denominator, reduce if possible, then set the denominator equal to 0 and solve for x. So, here's my equation. Here's my rational function. Does everybody see that it is a rational function? Right? Why? Because I have 2 polynomials that are being divided. Got it? Step 1, factor. Factor the rational function. So, you're going to do them separately. So, factor the numerator and then factor the denominator. So, on the top part, I have x squared minus 3x plus 2. Can I factor that? What do I need? What am I looking for? Factors of try that again? Of 2. So it's 1 times 2, which is 2, right? So factors of 1 times 2, which is 2, that add up to negative 3. What do you got? So then what is the factored form of the top? X minus 2, x minus 1. Does everybody agree with that? We good with that? Now on the bottom, I have x squared minus 4. Okay? I have x squared minus 4. Is this in the same form as the top part? Like, is there an a, b, and a c? Yes. What's my b? 0, because there's no x in the middle. Has everybody got that? So I'm looking for factors of what? Negative 4 that add to 0. So give me 2 numbers that multiply to give me negative 4 but add to 0. 2 and negative 2. So then the bottom can get factored as x plus 2, x minus 2. Does everybody agree with that? So there's my step 1. Same function, I just factored both the top and the bottom. Agreed? Step 2 said to do what? Reduce. Guys, when you're dealing with fractions, how do you even reduce them? What happens? You just cancel out. And usually that means that there's the same thing on both the top and the bottom, right? Because think about it. You're multiplying, right? This top part, these two things are multiplying. And then they're being divided. If I ask you to multiply and then divide something, what happens? Nothing, right? That's like if I come in tomorrow and be like, you know what, guys? I love you guys. Let's take your grade and multiply it by 2. And then the next day I said, now divide it by 2. Nothing happens, right? Your grade doesn't change. So that's the same thing. So do y'all notice anything here in my factored form? I have an x minus 2 and an x minus 2. So basically I can cancel those out. So then my new function, my now reduced function, is y equals what? Over x plus 2. Now that I've reduced, my last step says to take the denominator and set it equal to 0. Why? If I take the denominator, if I make this 0, then doesn't that mean that the denominator will be equal to 0? Right? So isn't that what we don't want that, right? But that makes sense because an asymptote is something that I can never touch. Right? An asymptote is something that I can never get to anyway. So do you see, first of all, my last step is I'm going to take what? X plus 2 equals to 0. What's my x going to be? Negative 2. So do you see that that means that I have a vertical asymptote? This means that I have a vertical asymptote at x equals negative 2. Which makes sense because that means I can never plug in negative 2 here to the bottom. I can never plug in negative 2 here to the bottom. Okay? Because I would have what then? I would have 0. Okay? So, actually, there's something interesting happens here too. Okay? Notice how I canceled them out, right? So, but I should have had 2 vertical asymptotes, but it got canceled out, right? Got canceled out. So this is not a vertical asymptote. This is actually a hole. So that's kind of, do y'all know what a hole is? A hole, remember it has that like, there's like no point there. So there's 2 things that happen. Here, I have a hole. So whenever you cancel something out, whatever it was, like whatever 0 it was, right? So here, this means that you have a hole at positive 2. Okay? You have a hole at positive 2, but you have a vertical asymptote at negative 2. Okay? How does that affect my domain? How does that affect my domain? Because what do these represent? What it can't be. I can never plug in 2 or negative 2. Does everybody see that? No matter what, if I plug in 2 here, 2 squared is 4. 4 minus 4 is 0. If I plug in negative 2 squared is 4. 4 minus 4 is 0. So I can't plug either one of them in. Okay, so how does that affect my domain? It can't be that. How do I write that? So there's 2 ways to do it. There's 2 ways to do it. Okay, so you've probably seen it as like, yeah, exactly like Daisy was saying, like a x is greater than or less than or whatever. Here's what I'm going to tell you how to write it, okay? I like intervals. Intervals are with the parentheses and the brackets, where it starts, where it stops. You know what I mean? So I like intervals. So I know for sure that I can't be negative from negative infinity to negative 2, and then I'm going to go from negative 2 to 2, and then I'm going to go from 2 to infinity. So I know that seems like a lot, but you have to be able to read it. So notice when I do intervals, do y'all remember that there's a difference between having like a parentheses and a bracket? What's the difference? What's the difference between a parentheses and a bracket? Like if I put brackets. A bracket includes that point. Okay? A bracket includes that point. So if I put a bracket, like first of all, you can never ever include infinity. Okay? So never have a bracket around infinity or positive. Why? Because you can never go to infinity. Right? You can never say here's infinity, because then I could say, well, there's one more. Well, there's one more. Right? So you can never reach infinity, so you can never include it. Make sense? Do I want to include negative 2? No, because I know if I plug in negative 2, I'll have a hole or a vertical asymptote, right? So students sometimes get confused. They're like, yeah, but so then why do you write negative 2? Because it's easier to say negative 2 but don't include it than negative 1.999999999 forever. You see what I'm saying? Right? Isn't it just to say, look, here's negative 2. Basically, it's kind of like a limit. It's saying, look, just negative 2, just don't ever include negative 2. As close as you can get to it, just don't include it. Okay? So here's what I'm saying. From negative infinity to negative 2, but don't include negative 2. And then I have to go from negative 2 to positive 2, right? So the stuff in between, right? Like negative 1, 0, and then everything in between. And then I have to go from 2 to positive infinity. Yes, ma'am. So good. So if nothing canceled out, I would just have 2 vertical asymptotes. A positive 2 and a negative 2. No, right now I only have 1. I only have 1 vertical asymptote. Because here's the thing. This is the process of finding vertical asymptotes. So we factor, we reduce, and then we set the denominator equal to 0. But if nothing would have factored, if let's just say that these wouldn't have canceled out, then I would have, when I set this denominator equal to 0, I would have 2 x's. So I would just have 2 vertical asymptotes. Okay? So the difference is here, because this canceled out, I still can't forget about it, because I still can't plug in positive 2. But instead of it being an asymptote, it's a hole. See the difference? Okay? And so, okay, does everybody understand my domain? Okay? We're going to keep going over that, okay? So the domain is, we want to say it in intervals. Say, where does it start to where does it stop? This one's kind of confusing because there's 2 stopping points, basically, right? But it's like, okay, from negative infinity to negative 2, and then from negative 2 to 2, and then from 2 to infinity. This U, it's a U. This right here? It's a parentheses too. Sorry. This right here, guys, this is a U. It stands for union. It's the math equivalent of and. Okay? It just means and. Okay? So yeah. So it's just a U. You'll see it looks like a U, but it just means union. It just means and. So what I'm saying here is from negative infinity to negative 2, and from negative 2 to 2, and from 2 to infinity. Okay? Sorry, I should have explained that. Okay, so, but actually you should have learned that in algebra 2. Okay. So, that's one way to say it, or I could just say this. X does not equal to positive negative 2. That is easier. So, I'll take either way. However, you have to understand if I say it in an interval, yeah, you have to understand both ways. Does everybody see how easy this is? This just says, look, your x can be whatever except these 2. Right? Your domain can be whatever except these. And sometimes it's not going to always be a positive, negative, the same number. So you might have to list two different ones, okay? Okay, so important part is the process. What is my process? Factor, simplify, set the denominator equal to 0. Okay? Factor, simplify, set the denominator equal to 0. What's the difference between a whole and a vertical asymptote? Just no point, so there's not like a line, right? Exactly, okay? And how do I know? The whole is the whole is the one that got canceled out. The vertical asymptote was whatever I had left, okay? All right, let's try another one. Same process. It's the exact same on the top, so you really don't have to copy it down if you copied it down already. It's just a different equation now. Hmm? Okay, so I have y equals 2x squared over x squared minus 1. Okay, so part 1 was factor. On that top part, can I factor it? So 2x squared, just 2x squared? So on the top part only. Can I factor that? No. There's nothing I can split it up into two things, right? I can't whatever. So it's just going to stay 2x squared. What about the bottom part? Can I factor that? Does everybody see it's kind of like the last one, right? It's x squared but minus 1, so then what are my x's? So it's going to be x plus 1, x minus 1. Is everybody good? So then part 2, Daisy, what's going to happen? Can I reduce? No, because there's nothing on the top that's the same as the bottom. So guess what? This is as reduced as it gets, right? You can't reduce. We can't reduce. And so then now, because, let me see how smart you guys are. My pre-AP, right? Because I can't reduce, am I going to have any holes? No, because holes only happen when something gets canceled out. So there's no holes. Actually, I'm just going to have what? 2 vertical asymptotes. Very good. Very good. Okay? So you're going to take the denominator, which is x plus 1, x minus 1 equals to 0. And this is very simple. What are my x's going to be? Negative 1 and positive 1. So what does this mean? This means you have a vertical asymptote at x equals to negative 1 and an x equals to positive 1. So you have 2 vertical asymptotes, no holes. Okay? You have 2 vertical asymptote, no holes. Give me my domain. That's a simple way of putting it, right? That's a simple, yes. No. Brackets, remember, brackets mean include this point. I still don't want to include positive 1 or negative 1. Nope. Say that again. So, wait, I'm going to get yours right now. Say your question. No, the answer is, I'm kind of asking a separate question. So the answer is where my vertical asymptotes, and this is where my vertical asymptotes. I'm just kind of adding something to say, well, what's your domain? Okay, so this is the easy way, and Daisy's trying to tell me what's the difficult way going to look like? Very good. Okay, very good. Again, I want you to see both. I don't care. I'll be honest with you. In calculus, we use this one more often. Okay, we use this one more often. Okay. So I do want you to see both. They mean the exact same thing. Basically just says, look, x can be anything except positive or negative 1. Well, that's what this means. Right? X cannot equal to positive negative 1. We good? Again, do I need to explain this again, like what it means? You understand why I have absolutely no brackets, right? Why? I don't want to include any of these points. Okay? Most students, for some reason, what? No, it's not some reason. I know why. They get confused. Well, so then why are you writing -1 twice? Well, but I am writing it twice, but neither of the time it's included, right? It's because I'm on this side. This is the left of -1, right? This would be considered the right of -1. This would be considered the left of +1. This would be considered the right of +1. Okay? But at no point am I ever including the points -1 and +1. Okay? Alright, do me a favor. I want you to try this one on your own. Try this one on your own. I want to know two things. I want to know where are my vertical asymptotes, and I want to know the domain, please. So, the first step is to factor. So, factor this for me. What do I get on the top? Okay, so that's what did everybody at least factor correctly? Okay, so you factor, okay, and then what do you notice? So those cancel. Now, before I even move on, something interesting happens there. Because I canceled, what happens? I have a hole at where? X equals to, it's not 4. It'd be a -4. Does everybody see that? Because it would be like setting it equal to 0. Right? So does everybody see that? I have a hole at -4. Okay? So now, when I reduce, I'm left with what? X plus 3, X minus 4. Correct? And then how do I find my vertical asymptote? You set the denominator so X is equal to what? So what does this represent? So I have a vertical asymptote where? At +4. So I have a hole at -4. I have a vertical asymptote at +4. So out of all that, can you give me my domain? It's basically X can't be those two numbers. Is that okay? So the complicated way, it's not complicated. Mm-hmm. Very good. Uh-huh. Uh-huh. Good. Mm-hmm. Perfect. Perfect. Uh-huh. Okay. So, basically, just finding my vertical asymptote can tell me three things. It can tell me, of course, find me my vertical asymptote, because that's the point of doing that. It can find me any holes that I have, and again, how do holes occur? When something cancels out, right? So there's a hole there. So it's not a vertical asymptote, but you still couldn't plug in that X. That's why it's a hole, right? And then it also can help you with your domain. Any questions so far? What look like? The holes? Okay, so I can sketch this for you real quick. I know I have a vertical asymptote at +4, so 1, 2, 3, 4. So I know there's a line there. You know how the parent looks, right? So it should look something like this. Right? On your calculator, you won't see a thing. But here, in the real world, basically, here, at 4, it would look like this. Literally a hole. No, doesn't it? No, because look at your domain. Doesn't it exist that way too? Okay. So on your calculator, you won't see a thing. I don't care how much you zoom in. It'll just, it's kind of, calculators are not the answer. They're just a tool. So you have to understand things before you use them. So the calculator knows that there's a hole, but it just has no way of saying, oh, it's not going to put an actual missing point. Okay? Any questions? All right. So one more time. VA stands for what? What do they look like? Vertical lines, right? They're vertical dashed lines that I can't touch, correct? How do you find it? Factor, reduce, set the denominator equals 0. So we go with vertical asymptotes? Good. Let's move on. Let's talk about horizontal asymptotes. Okay, let's talk about horizontal asymptotes. So, obviously the difference between a vertical and a horizontal asymptote is this one's a horizontal line. Okay? Notice the equation. It's represented not by x equals, this time it's going to be y equals. Okay? Again, by some constant. So it's going to be y equals some constant. Okay? And it's the exact same thing. So it's a function approaches and gets infinitely close to. Okay? So do y'all see it's the same picture as the last time. Is there a horizontal asymptote here? Yeah, you see it right here? Okay? Students get confused though because of what is happening right here. It's going through it. Right? So horizontal asymptotes, they're kind of like an asterisk. Okay? So it's kind of like, yeah, you can't really, the ones who really pay attention are the outside parts of the function. Okay? Inside, so many different things can happen, but really it's the outsides. Notice that the outside here, it's approaching but never touching, right? And this one approaching but never touching. That middle, it's kind of ignores it. So this one would be y equals to 1. Okay? To find a ha, it's actually easier. The vertical asymptote, that was the most math. Okay? To find the ha, all there is 3 rules. Okay? All you have to do is know the rules. So, here are the rules. Do me a favor, copy this down, and then we'll talk about it. Let's talk about this. Okay? Alright, so it says here, to find horizontal asymptotes, guys, all I have to do is compare the degree. By the way, what's a degree? What's a degree of a function? Okay? So the degree is the highest exponent. So all I have to do is compare the degree of the numerator to the denominator. Numerator, of course, is the top part. The denominator, of course, is the bottom part. So all I'm doing is comparing. So there's only 3 things that can happen. Either the numerator is smaller than the bottom, that they are the exact same, or the numerator is bigger. Does everybody agree with that? There's only 3 situations that can happen. Okay? So, here are the rules. If the numerator is smaller, if it's less than, I like to say less than. So if the numerator is less than the denominator, automatically your horizontal asymptote is just y equals 0. Okay? Automatically it's just y equals 0. By the way, y equals 0, that's your x-axis. Okay? So automatically, if the numerator is smaller than the denominator, it's just y equals 0. Okay? If they are the same, so the numerator, of course, is equal to the denominator, then your horizontal asymptote is a ratio of the leading coefficients. Okay? What are coefficients? The numbers in front of the axis. So all you do is just take a ratio. So whatever the 2 front numbers are, you just put the top over the bottom. Sometimes it'll reduce, sometimes it won't. And so it's just going to be y equals to whatever those numbers are. Okay? And then finally, of course, the last one, if the numerator is larger than the denominator, then there is no horizontal asymptote. Okay? So, one of 3 things happens. It's either going to be y equals 0, it's either going to be a ratio of the leading coefficients, or there is none. Highest exponent. Okay? Does everybody understand? No math involved. Literally no math. I mean arithmetic. All I'm going to have to do is be comparing numbers. You should be able to do this. I could teach an elementary student how to do this. Okay? Let's look. Here we go. So, all I'm asking you to do here is find the ha. Find the horizontal asymptote. Here's your equation. Y equals x squared minus 3x plus 2 over x cubed minus 5x squared minus 2x plus 3. Y equals x squared minus 3x plus 2 over x cubed minus 5x squared minus 2x plus 3. So, what am I looking at? The degrees. What's the degree of the top? 2. What's the degree of the bottom? 3. So, does everybody agree that the numerator is smaller than the denominator? So then what does my rule say? So the ha is y equals 0. Simple as that. So the horizontal asymptote is where? At y equals 0. Okay? Because that's part of your rules. Your rule says, if the numerator was smaller than the denominator, the degrees, then automatically it's y equals 0. Okay? So that I have a ha, you can put at. That's an at. Let's just pretend. Okay? So, shh. Does everybody understand how easy that was? That's all. So when I say find the horizontal asymptote, that's what you're doing. Okay? So, let's try another one. I have y equals x cubed minus 5x squared minus 2x plus 3 over x squared minus 3x plus 2. So here's my equation. So, I have x cubed minus 5x squared minus 2x plus 3 over x squared minus 3x plus 2. So, I'm just asking you to find the ha. What's the degree of the top? What's the degree of the bottom? So the numerator is larger than the denominator. So according to your rules, the ha is none. There is no ha. Okay? There is no horizontal asymptote. We good? Sure? Okay. You try this last one. For this function, I have 3x squared minus 2x plus 3 over x squared minus 3x plus 2. What's the degree of the top? 2. What's the degree of the bottom? 2. So then they're actually the same. According to your rules, your ha is at y equals what? So remember, it's a ratio of the leading coefficients. What are my leading coefficients? 3 and 1. So it's y equals 3 over 1 or just y equals 3. That's it. We good? So, ha stands for what? What does that look like? It's a horizontal line that what? The function cannot touch. Now remember, I kind of put an asterisk because that usually is to the outside parts, right? The inside can, I'm not saying it will, but it can go through it. Okay? And then, how do you find the ha? You're just comparing the degrees, right? You're just comparing, all you're doing is comparing the degrees. Okay? We good? Alright, so we know how to find a va. We know how to find a ha. Now let's talk about our sas. What's a slant asymptote? So, think about what it would look like. It's a slanted line. Okay? It's a slanted line. So, a slant asymptote is a linear function. That means that it's the y equals mx plus b. It's a linear function that acts as an asymptote to a rational function. The rational function, again, will get infinitely close to this linear function. So I gave you a quick little example. Do you see how I have this slant asymptote right here? Okay, you see how the function looks? Notice it's not straight, it kind of like makes like a little V shape, right? Basically, it's hugging the vertical asymptote and the slant asymptote. But again, notice what happens in the middle. It can cross, okay? So the middle of a function usually just doesn't pay attention to anything, right? It just does whatever it wants to do. So it can go through slant or horizontal asymptotes. Okay? So, here's the important part. slant asymptotes are in the form y equals mx plus b because they're linear functions. They're lines, right? They're lines. My slant asymptote is essentially a line. Okay? So, the important part is, well, how do you find slant asymptotes? So first of all, here's the big key. Slant asymptotes occur when there is no ha. So, you cannot have both a ha and a sa at the same time. Has everybody got that? It's either one or the other. So, if there is no ha, that means that the degree on the top was bigger than the bottom, correct? That's what our rules say. So, the way I'm going to do that is the way I'm going to figure out what my slant asymptote is, I'm going to divide. Do we know how to divide polynomials? Yeah. Okay? So that's why we learned it. That's why we learned it. So, we're going to divide our polynomials, and then here's the important part. We're going to ignore our remainders. Okay? So we're going to divide the way we divide normally, and then just ignore the remainders. Whatever I get as my answer, that is where my sa is. So, first, when you're dealing with slant asymptote, always check to make sure there's no ha first. Okay? Don't just start dividing like crazy. Make sure there's no ha. Okay? So, here's my equation. F of x equals x squared minus x divided by x plus 1. F of x equals x squared minus x divided by x plus 1. All I'm asking you to do here is find the slant asymptote. So first of all, check, is there a ha? What's the degree of the top? What's the degree of the bottom? 1. So the numerator is bigger. So does everybody agree that there is no ha? Alright? So now that I know there's no ha, I can move on to find my sa, my slants, okay? So I'm just going to divide. We know how to divide. X squared minus x divided by x plus 1. Actually, in this case, I could use what? Could I use the synthetic? Why? My divisor is simple, right? My divisor is simple. I'm going to use long division because it's not always going to be simple, so we got to make sure we know how to do this. So, how do I do this? What am I looking at? Just the x and just the x squared. So, x times what will give me x squared? X. So, x times x, and now what do? Multiply this times x plus 1, which would give me x squared plus x. But then what happens? So this becomes minus, and actually this becomes minus. So that cancels, and actually this becomes negative 2x. We good with that? Now I ask myself, x times what will give me negative 2x? Negative 2. Negative 2 times x is negative 2x. Negative 2 times a positive 1. Negative 2. This becomes plus. This becomes plus. This cancels. I'm left with. But what did I tell you? Ignore it. So then where is your sa? Remember, it should be y equals mx plus b. So it's going to be y equals x minus 2. Is this in the mx plus b form? Yeah. What's my m? 1. What's my b? Negative 2. So there you go. So there's my slant asymptote at y equals x minus 2. So, how do you find a slant asymptote? First, make sure there's no ha, and then I simply divide. We good? Sure? Let's try another one. So here's my equation. I'm going kind of slow on this because it's actually really important. I want to make sure that everybody gets this before we... I know before I tend to move a little quicker, but it's really important. This is the actual stuff you need before calculus. Okay? So I have y equals negative 3x squared plus 2 over x minus 1. Is it a rational function? Yeah, it's a rational function. It's a polynomial divided by another polynomial, right? What's the degree of the top? What's the degree of the bottom? So what does that mean? There is no ha. There is no ha, so I can proceed to find my sa. How? Negative 3x squared plus 2 divided by x minus 1. Actually, do you guys want to use synthetic? Let's try synthetic. Can I use synthetic? Because it's a simple divisor. Okay, let's try synthetic. If I use synthetic, what's going to go here in my little box? A positive 1. And then what are my coefficients going to be? Negative 3, 0, and 2. Why do I have a 0 there? There's no x. Does everybody see that? So be very careful when using synthetic. So I don't have an x. So this represents my x squared. This represents my x squared. This represents my x. This represents my constant. So now, what are the steps? Drop the first one, so that's a negative 3. And now 1 times negative 3 is? Negative 3. Add. Negative 3. Multiply. Negative 3. Add. Negative 1. What does this represent? And I just told you what? Don't worry about it. So then, my sa is at where? You have to make it y equals, people, because it has to look, it's an equation of a line. Okay? It has to be y equals. So my sa is at y equals negative 3x minus x. Are we good? Too easy? Make it harder? Do me a favor. Why don't you try this one on your own? Try this one on your own. So first of all, I'm finding the sa, which means I have to make sure what? There's no. So what if there is a ha? Then there's no sa. Okay? If there is a ha, then there is no sa. You're done. Okay? So here's the thing. What's the degree at the top? What's the degree at the bottom? So that means that there is no horizontal asymptote. So now I am going to use long division. Okay? And you can use whatever you want. In this case, I didn't tell you what to use, right? So you can use whatever you want. So I'm going to see x times what will give me x squared? X. So multiply. That should give me x squared minus 2x. But then that's going to change to a negative positive. That will give me 5x plus 2. X times what will give me 5x? So positive 5. 5 times x is 5x minus 10. That gives me a minus positive. Then I should end up with a 12. This is my... I ignore it. So where is my sa? Everybody get that? Good? Good? Okay. So, recap. SA stands for slant asymptote. What does that look like? A line. A line. It's a linear equation, which means it is in the form y equals mx plus b. Okay? It can be in the form y equals mx plus b. How do you find it? Make sure there's no ha. And divide. Divide. We good? So, now we know how to find three things. We know how to find a vertical asymptote, which, again, say that. How do you find a vertical asymptote? So, factor reduce, set the denominator to 0. And actually, just by finding the vertical asymptote, it also helps me find what? Domain, and if there are any holes, right? So vertical asymptote kind of hits three spots for me. It helps me find my domain. Not only does it help me find my vertical asymptote, it helps me find my domain, and it helps me find any holes if there are any. When do holes occur? When something cancels, right? So you still can't put that x in, so that's why it shouldn't be. It's not part of your domain, but it's not a vertical asymptote. It's a hole, right? And then how do you find a horizontal asymptote? Compare the degrees, and you got three rules. Only one of three things can happen. And then you have a slant asymptote doing that, okay? So usually, guys, this is called analyzing a rational function. Basically, I tell you, analyze this rational function. So I give you a rational function, and I want you to tell me everything you can about it. So I never just say, find the vertical asymptotes or find the horizontal asymptote. I say, find me the asymptotes. So you have to basically hit all the spots, if there are any, okay? So, here we go. Um, I want you to basically sketch the graph like I did in the first example, right, Daisy? I want you to sketch a graph. But in order for me to do that, here's what I have to do. I have to know the x and the y intercepts and all asymptotes. Okay? And then I'm going to test some points around the asymptotes to discover where the graph exists. Okay? So, first of all, when I tell you to do this, here's all the information I want. Okay? I want to know the x-intercept. I want to know the y-intercept. I want to know if there are any holes. I want to know if there are vertical asymptotes, horizontal asymptotes, slant asymptotes, and then I want to know the domain. So, you know how to do all of this. You know how to do all of this for every problem. Okay? So, let's try. Yes. For what? The saw? Uh-huh. Oh, you're trying to factor? You don't have to factor, because that's as simple as it, right? Okay, so here we go, here we go. Let's start with this. So we didn't talk at all about x and y intercepts because you should know how to do it already. How do you find an x and a y? How do you find an x-intercept? Set y equal to 0. So for x-intercept, this is something that we did at the beginning of the year, right? Y is equal to 0. So in our case, what would our equation look like? 0 equals 3 over x minus 2. Okay? So, and then solve for x, right? So guys, can you tell me some algebra here? How would I solve for x? Yeah. Yeah, what would I do to get x by itself? So this one's tricky because look, it's 3 over x minus 2. The x is on the bottom. I don't want it on the bottom. So couldn't I multiply both sides by x minus 2? Right? Which it'll cancel on the right. But actually what happens over here? 0 times anything is what? So actually, there is no x-intercept. Okay? So if I can't find an x, guess what? There is none. There are no x-intercepts. Okay? How do you find a y-intercept? You make x equal to 0. So what does that look like in our case? Y equals 3 over 0 minus 2. Does everybody agree that that's just going to be y equals 3 over, or negative 3 over 2? Which are they? Right? Does everybody see what I did? All I did was make x 0, so then that just becomes negative 3 over 2. So there's my y-intercept. Y equals negative 3 over 2. Okay, so now I'm talking about holes, but when do I even find out if there are holes? When I'm doing a vertical asymptote. So let's go to vertical asymptote. So, vertical asymptote. What do I do? Factor. Can I factor the top? Can I factor the bottom? Can I simplify? Nothing cancels, so then basically I'm just going straight to the what? Set the denominator equal to 0. So in our case, x minus 2 equals 0. What's my vertical asymptote? 2. So my vertical asymptote is x equals 2. So because nothing canceled out, what else do I know? Say that again, Bonnie? There's no holes. There's no holes. We good? Okay, so Alexis is also telling me, look, there's no holes and I have a vertical asymptote. So then my domain, it cannot be 2. Right? So let's write that the complicated way. How do I write it? How do I make it to where it's not 2? To 2. This one doesn't have 3 parts because there's only one x. Got it? So this one only has 2 parts. Negative infinity to 2 and then 2 to infinity. Right? We good? Sure? Okay. Let's talk about our ha. Let's talk about our ha. What's the degree of the top? 0. Technically, there is an x. Guys, anything to the 0 power is what? 1. So technically, there is an x to the 0 power because there's a times 1, which is still 3. Does everybody agree with that? So the degree of the top is 1. The degree of the bottom is what? 1. So they're the same. So it's y equals what? 3. So I have a ha at y equals to 3. Because I have a ha, there is no sa. So look at all that information we know how to find. Look how smart you guys are. I don't care what your parents say. Okay? Sorry. Okay? Alright? So, can I give a pretty decent sketch now? You should be able to. Like, for instance, I know for sure I have a vertical asymptote where? At 2. I know I have a horizontal asymptote at 3. I know I cross the y-axis at negative 3 over 2. 3 over 2 is like what? 1.5. So does everybody agree like right here? Okay, so that actually gives me a good hint because you know what the graph should look like, right? It should somewhat resemble this, right? And that tells me that there's a point down here. So then that also tells me that the other one is over here. Because they have to be across from each other, right? Or they got to be opposite somehow. So there you go. So you see how this works? Okay? This is how I will ask you the questions. I won't simply say, find me the ha or find me the va. I'm going to say, analyze this rational function. So do you see how this is kind of like calculus, right? It's very, I gave you one equation and you're giving me all this information. Okay? Are we okay with that? All right, I think we should finish this. Let's try another one. Let's try another one. I know we taught all class, but I want to finish this video. instead of making 2 parts. So, what is all the information I want? X-intercept, Y-intercept, holes if there are any, vas, ha, sa, and domain. Okay? You should be able to tell me all of this stuff. Okay? Let's start with the x-intercept. Okay? So, that would give me 0 equals x over x squared minus x minus 2. Right? You see how this is the same situation as last time? Since I'm dividing, what would I do? Multiply it by this on both sides. Y'all see what's going to happen? I get 0 on this side equals to what? X. There's 1. So my x-intercept is 0. Right? Because I actually found it at 0. Right? And if you want, you see what happens, right? Still 0. Okay? So there's the x-intercept. The y-intercept, how do I do that? So I get, so y equals 0 over 0 squared minus 0 minus 2. 0 over what? Negative 2, which is still 0. Can I have 0 on top? Yes. I just can't have 0 on the bottom. Okay? So my y-intercept is also y equals 0. Okay? Now to find my holes, I have to go to my what? To my vertical asymptote. Okay? So, factor, correct? Can I factor the top? Can I factor the bottom? So what am I looking for? Factors of -2 that add up to -1. What do you got? -2 and +1. Is anything going to reduce? Is anything going to cancel? No. Which means no holes. Okay? And actually, so I'm going to have what here? 2 what? I'm going to have 2 vertical asymptotes. What are my 2 vertical asymptotes going to be? +2 and -1. You good with that? There's no holes because nothing got canceled. So can you tell me my domain now? So we'll put it the easy way this time. We'll say x does not equal to 2, and then you can just put a comma and say or -1. Okay? So x does not equal to 2 or -1. The vase and the holes. Okay? Because those are the x's that can't happen. All right. For ha, what's the degree of the top? 1. What's the degree of the bottom? So that means my numerator is smaller than my denominator. If your numerator is small, according to your rules, what? Y equals 0. Because I have a ha, there is no sa. And then you could just sketch it from that information. See how smart you guys are? Any questions? So, I know it's a lot of information, but it's just systematic, right? You're just looking, you got to understand what's what and how to do it. Okay, let me see. There's one more. I'll do it. It'll be on the video. It'll be on the notes, okay? It'll be on the notes in the video. So you can just get it later.